Now, let z bar denotes the complex conjugate of a complex number z, and if z is a non-zero complex number for which both real and imaginary part of z bar square plus z square are integers, both the real and imaginary parts, then which of the following is or are possible for modulus z? See, this question really it was a little bit difficult for me to solve it because no link, I was getting no link here, and I have solved it, but if anyone has any objections, you can place in this comment section. But I have solved it. I find little bit difficult to solve it, but while doing some hit and trial methods, I got a result, and on the basis of that result I moved further, but it was really difficult for me to solve it. And again I'm repeating you, I'm solving it for you. But if anyone has any questions, you can place in the comment section. Here, after trying some hit and trial method, I got one conclusion. See, what is the conclusion I got here? You see this z bar square plus 1 by z square. Now, if you take the LCM, z square, so this will be z bar square into z square plus 1. Now, so here you know that z bar into z is equal to modulus z square. So this will be modulus z to the power of 4 plus 1 by z square. Now, what I did here is that again I multiplied the numerator and denominator by z bar square. So here again I got modulus z4 plus 1 by modulus z4 and z bar square. So these are all scalar quantities, because magnitude we are going to get some values. Now if I take z, let us take this z is equal to a plus ib, then your z bar will be a minus ib. So z4 plus 1 by z4, when you square this, what are you going to get? That is let us take a plus ib, x plus iy. So this will be x minus iy the whole square. So here you are going to get, see, z4 plus 1 by z4, and here you are going to get here x square plus y square minus 2xyi. Similarly, now let me do some change here, that is z square plus 1 by z bar square. So again LCM, that is z bar square, so z square into z bar square plus 1, so this will be modulus z to the power of 4 plus 1 by, again I am multiplying both sides by z, so z square, so this will be modulus z4, and when I expand this z square, that is x plus iy the whole square, I am going to get here, see, z4 plus 1 by z4 plus 1, and this is x square plus y square minus 2xyi, plus. So here you find that you can treat this, see, k times, this is A and this is B. So you can treat this as A plus IB. You can treat this as A plus IB. You easily treat, because these are all magnitude. So this is A real and, not plus, this will be minus. You can treat this A minus IB, and here you can treat this as A plus IB. So this is the conclusion I got here. So now what I did is that because here it is both the real and imaginary are integers. Both these are integers. So what I did here is that plus 1, I multiplied these two. When I multiplied these two, what I got here is that is z4 plus 1 by modulus z4 the whole square, and this will be x square plus y square the whole square minus this will be how much? This square, so 2x y I the whole square. So this will become how much? This will come out to be modulus z4 plus 1 by modulus z4 the whole square, and here this will be 4x square I square minus plus, and I square minus 1, so minus 1, and a square minus b square. Okay, so here this will be x4 plus y4 plus 2x square y square, and this will be 4 minus 4y I square, that means minus 1. So this comes out to be plus, minus plus, because this will come out to be plus 4x square y square. The result will be somewhat like this. Now here I made a slight mistake, that is I made a slight mistake here. So what I got the result, that is z bar square plus 1 by z square can be written as a minus ib, and your z square plus 1 by z bar square, this can be written as a plus ib. This is the conclusion which I got after trying some hit and trial method, but it was really a difficult question to solve because there was no link I was getting here. So if you suppose here x plus iy conjugate square, the question will it will go on increasing, and it will be difficult for you to solve it. So what I got, this can be written as a minus ib, and this can be written as A plus IB. This is the conclusion I got. Now I have to multiply this. So when I multiply this, so what do we get? Z bar square plus 1 by Z square into Z square plus 1 by Z bar square is equal to A plus IB into A minus IB. That will be A square plus B square. So now if we take the LCM here, so this will be how much? Z modulus Z4 plus 1, and this will be modulus Z4 plus 1, and in the denominator it will be modulus Z4 is equal to A square plus B square. So such type of result I have got here. Now here you see that this can be written as modulus Z4 plus 1 the whole square by modulus Z4 is equal to A square plus B square. I can write like this. So here again, if I enter this Z4 inside this bracket, so it will be somewhat like this. Modulus Z4 plus 1 by modulus Z square the whole square is equal to A square plus B square. Now if I divide this LCM, it will be modulus Z square plus 1 by modulus Z square the whole square is equal to A square plus B square. So the result comes out to be modulus Z4 plus 1 by modulus Z4 plus 2AB, that is 2, is equal to A square plus B square. So this is the last result I got here, that is modulus Z4 plus 1 by modulus Z4 plus 2 is equal to A square plus B square. This is the last result. So now I had no other option. I just first I tested by placing this here. That is, this hole I placed here in place of Z, this hole in place of Z. When I placed here, you will see that what happens, you see. This result. So this will be how much? Z, so 1 by 4 cancels out. So 43 plus 3205 by 2, and this is inverse. So 2 by 43 plus 3205 and plus 2 is equal to A square plus B square. So now 205, 5 4s are 20, 5 1s are. Now here what I did here, I rationalized it. 43 plus 3205 by 2, rationalize it. 43 minus 3205 by 43 plus 3205 plus 2 is equal to A square plus B square. Oh sorry, into 43 minus 3 root 205. So here this is 43 plus 3 root 205 by 2, and this is how much? 86 minus 6 205, and in the denominator it is 43 square minus 3205 the whole square and plus 2 is equal to a square plus b square. So now again here see here, that is so here this will be 43 plus 3 205 by 2 plus 86 6205 and 43 square. How much will be 43? 43 into 43, 3 3s are 9, 3 4s are 12, 3 4s are 12, 3 3s are 9, 3 4s are 12, 4 3s are 12, 4 plus 61 17. So 9481. So this is 1849 minus 9 into 205 plus 2 is equal to a square plus b square. So this is 43 plus 3 205 by 2 plus 86 minus 6 205 184 9 5s are 1849 9 5s are 45 9 2s are 18 a square plus b square. So again 149 minus 45, this will be how much? 4. So 43 plus 3 205 by 2. So here let the 2 common be here. So this will be how much? 43 minus 3 205 and this will be how much? 4. So here this cancels out. So plus 2 is equal to a square plus b square. Now if you take here LCM, you will see that if you take the LCM, you see that 43 plus 3 205 plus 43 minus 3 205 plus 4 is equal to a square plus b square. So this cancels out. So ultimately 43 plus 43, that is 86. 86 plus 4, 90 divided by 2, 45. So 45 is equal to a square plus b square, and it has been told that both the real and imaginary are integers. So 45, it is integer, both real and imaginary are integer. And you can check this also, this, but I have checked it. In every case you will get a fraction. Only this is the case where you get a whole number, that is integer. So this is the answer. So this question was really a tough question for me because it took certain work, hard work to come to a conclusion, because here see such type of conclusion, I am again repeating it, that the conclusion, such type of conclusion, that is this one, such type of conclusion, that is z bar the whole square plus 1 by z square, is you can treat as a minus ib, and z square plus z bar the whole square you can treat as a plus ib. So such type of conclusion, it took me little time to solve it, and I have checked for all this, and for all this I have got fractions, only for this I have got integer. So you see that I have the question, I have just shown you why I have considered this. In earlier, I have shown you why I have considered a minus ib and why this is considered a plus ib. After that, it is general, that is you multiply this two. When you multiply it, you get, see here, you multiply it here. So here when you multiply it, so see this. So I have entered this z4 inside it, and then I divided the LCM, and so Z, if you consider this as modulus Z, then you get integer. So it was really a tough question.